In this video, we're going to talk about our final type of conic section called the hyperbola. So just like in the previous two videos, we're first going to go over a few formulas, and then we'll get into some examples where you can use the formulas in a more visual way. So if you notice, the hyperbola equation looks pretty similar to the ellipse equation. The only difference is we have a minus sign in between our two terms rather than a plus sign. And so that's really the biggest difference between the hyperbola and the ellipse. Your center of this equation is still going to be the point HK. Your foci will be H plus or minus some distance C, and then K. And so if you notice, this time what we're looking at is the orientation of our hyperbola is going to be determined by the variable with the positive sign. Okay, so in this first column, what we're looking at is a hyperbola that is in this direction. Okay, so it's got that sort of horizontal orientation to it, whereas the other column is going to be the vertical. Okay, so that's why on the foci, we're adding to the x-coordinate rather than the y-coordinate in this case. Okay, so A and B are not necessarily the bigger and smaller number this time, it's the positive and negative term. All right. Anyway, so the vertices will also be adding to the x-coordinate, so we'll have h plus or minus our distance a, comma k. The transverse axis you can think of with ellipses like the major axis in the respect that it contains the foci. So this isn't necessarily the longer axis, but it is the one that contains your focus points. Okay, and that will be of length 2a in the horizontal direction. Okay, the conjugate axis you can think of in terms of the minor axis with ellipse in the sense that it does not contain the foci. So this will be of length 2b in the vertical direction. We also have our distance between the foci, which will be 2 times c in the horizontal direction. And with hyperbolas, we also have the idea of an asymptote. So an asymptote, if you remember from algebra, is a line on your graph that your graph approaches but never actually touches. And these will be diagonal intersecting lines of the form y minus k is equal to plus or minus b over a times x minus h. So if you notice, I just wrote the equation of a line in point slope form where the slope is determined by those letters a and b. Okay, so now let's look at the vertical case. So a vertical hyperbola will look something like this. Okay, and so your center is still HK. The foci will add to the y-coordinate rather than the x-coordinate, so we get hk plus or minus c. The vertices are similar. We'll add to the y-coordinate rather than the x-coordinate, so we get hk plus or minus a. The transverse axis will be of length 2a in the vertical direction. The conjugate axis will be of length 2b in the horizontal direction. And the distance between your foci points will be 2c in the vertical direction. All right, and finally, the asymptotes for these types of hyperbolas will be y minus k is equal to plus or minus a over b times x minus h. Okay, so really similar to the horizontal case, it's just been flipped around. All right, so let's draw a little bit more detailed of a picture of each case, just so you can see exactly what these are going to look like, all right? Just like we did in the previous video. So for the horizontal case, let's draw some axes here, and let's say that our center is maybe right there, okay? So what's going to happen is A and B are going to determine a box around this center, okay? Sort of like when we graphed an ellipse, except you're not going to connect those dots to form an ellipse, you're going to connect it to form a dotted box. So we'll end up with a box shape that looks something like this. And the importance of this box is that it's going to determine your asymptotes really nicely. So the way to get your asymptotes is you just connect the corners of the box through your center point. All right. And since we're dealing with a horizontal hyperbola here, your vertices will be on the horizontal axis away from your center, but they will be located on that dotted box. Okay, so these would be your vertices, so we'll call them maybe V1 and V2, and your curve will just go through the vertex and then approach your asymptote on either side, but not cross. So whenever you're graphing these, be very careful that your curve does not cross those asymptotes. Okay, so that's the idea of a horizontal asymptote, and your foci will be located some distance away from those vertices, but inside of the curve. So we call that focus 1 and that focus 2. Okay, so that's the idea of a horizontal hyperbola. Let's look at the vertical case. So in the vertical case, let's say that our center is right there, and maybe because of A and B, we get a box that looks something like this. Okay, now again, your asymptotes would be determined by lines that go through the corners of your box and through the center of your hyperbola. And so we might get some asymptotes that look like that. Now this time, since we're dealing with a vertical case, your vertices will be on the top and bottom of the box in line with your center, and your curve will just approach those asymptotes. Okay, and so we might call that V1 and V2, and then your focus will be somewhere inside of those curves. So we might call that focus 1 and some focus down here, focus 2. Okay, so those are basically what the two different kinds of hyperbolas look like. Okay. Now, again, we have a length of a latus rectum, but we don't use it very much, but I'll tell you what it is anyway. So it's 2b squared over a. The eccentricity of a hyperbola is the same as the eccentricity of an ellipse. That'll be c over a, but this time, to find that letter c, we have a slightly different formula than with ellipses. So remember, ellipses where c squared is a squared minus b squared. But with hyperbolas, we change that minus to a plus. Okay, so that's really the most important formula for you to remember, besides the actual equation of the hyperbola. Okay, so let's move on to some examples. So I put some steps here just to remind you, because I think hyperbolas are probably the most complicated of the three conics to graph, but if you follow these steps, you shouldn't have any problems. Okay. So for the first example, we're going to find the vertices, foci, asymptotes, and then sketch the graph of x squared over 64 minus y squared over 36 is equal to 1. Okay, so the first thing that I would do is determine which way this is oriented. Now, because x is the positive term of your hyperbola equation, we know that this is going to be a horizontal hyperbola. Okay, so it's not because 64 is bigger than 36, it's because x squared is the positive term. Okay, so it's horizontal, and we know that the center is 0, 0. So again, just like in the previous videos, for now we're going to assume that the center is 0, 0. In the next video, we'll talk about shifting the center away from the origin. Okay, now, because this is horizontal, 64 becomes a squared, so a is equal to 8. B is going to be the square root of 36, which is 6. And so now we can actually start graphing this hyperbola. So let's go ahead and put some axes down. And I'm going to make the x-axis a little bit longer because I know that this is going to be horizontal. But again, just because it's horizontal doesn't mean that it's longer in the x-axis direction. Okay, so because a is 8, we'll have 2 points at, well, our center is 0, 0, so I'll go ahead and graph that. And because a is 8, we'll have a point out at 8 units away from C, which would be 8, 0, and also 8 units in the negative direction, so we'd also have negative 8, 0. Okay, Because b is equal to 6, we'll have a point 6 units up from c. So we'll have 0, 6. And we'll have a point 6 units down from c. So this would be 0, negative 6. Okay? So these are the 4 points that determine our box. And you might think that it looks a bit like when we graphed ellipses, but this time instead of connecting it with a curve, we're going to draw a box. All right. Okay, so now that our box is drawn, we want to put in our asymptotes. So again, to do this, we connect the corners of our box through the center of the hyperbola. And so your asymptote should look something like this. Okay? And so you notice that because this is a horizontal hyperbola, our vertices are going to come from the 2 points that are on the horizontal axis in line with the center. So our vertices will be negative 8, 0 and 8, 0. Okay? So the curve is going to come from those 2 points and approach your asymptotes on either side. So it will look like this. Okay, so the last thing we need to find are the foci and the asymptotes. And to find the foci, we're going to need the variable c. So we know that c squared is equal to a squared plus b squared, which is 64 plus 36, which is 100. So c is equal to 10. Okay, so again, c is the distance between your center and each of your foci. So we'll go 10 from the center in the negative direction. So that might be about right there. So that would be negative 10, 0. And your focus in the positive direction will be 10 units from the center. So that would be 10, 0. Okay, so your two foci points are negative 10, 0 and 10, 0. Okay, and again, if you want to label all of these points with letters instead of ordered pairs, that's fine. Just write off to the side which letter each of those points is. Okay, and then finally we need to find the asymptotes. So I know I gave you a formula, but I think it's a little easier to think about this just like you did in algebra. Just get the equation of a line. Okay, so asymptotes. The most important thing about this is the slope, okay? So first of all, both of our lines go through the center. So the center is going to be the point that we use for our point slope form, okay? So we know that this is going to be y minus 0 is equal to some slope times x minus 0, okay? And that slope we'll get from the box. So you can go back to your most basic definition of a slope, which is rise over run. So from the center, in each direction, we go up 6 units and over 8 units. So the slope is 6 over 8, which reduces to 3 over 4. And this should really have plus or minuses on each, because we have one line at the positive slope, one line with the negative slope. So the equation of your asymptote then is just y equal to plus or minus 3/4 times x. All right, and that's all there is to it. So again, this is the most complicated of the conics, but I think if you follow all the steps, you should be okay. All right, let's look at another example. So if you notice, this one is not quite in that standard form that we like. We have 4x squared plus 36 is equal to 9y squared. So the first thing we need to do is get this into its standard form. So that means we need x squared and y squared on the same side of the equation, and we need the constant term on the other side. So if we subtract 9y squared to the left and subtract 36 to the right, we get 4x squared minus 9y squared is equal to negative 36. And the last thing we need to do to get this into standard form is divide every single term by a negative 36. so that we get a 1 on the right side. Okay, so what this is going to do is this is going to flip the order of our terms, because I like to write the positive term first just so I don't miss any negative signs. So what we'll get is y squared over 4 minus x squared over 9 is equal to 1. Okay, so this is the standard form of our hyperbola. Okay, and again, you'll notice the center is 0, 0, and it is oriented vertically this time because y squared is the positive term. Okay, but notice that 4 is less than 9, so the size of 4 and 9 has nothing to do with it. It is simply what letter has the positive sign. Okay, so let's go ahead and put down some coordinate axes, because we'll go ahead and draw this as we're analyzing it. Okay, so A is going to be 2 because it's under y squared, which is the positive variable. B is going to be 3 because it's the other letter. So we'll start with our center at 0, 0, and we'll go 2 units in each vertical direction. So we get 0, 2 and 0, negative 2. And we'll go 3 units in each horizontal direction from the center. So we get 3, 0 and negative 3, 0. Okay, so these 4 points are what determine our inner box. And so we'll go ahead and sketch that box. And we can go ahead and get our asymptotes. Okay, so because we said that this hyperbola will be vertical, our vertices are going to be the points on the top and bottom of the box. So our vertices are 0, 2 and 0, negative 2. To find our foci, we need to find that variable c. So again, c squared is a squared plus b squared, which is 4 plus 9, which is 13. So c is the square root of 13. Okay, so our foci will be square root of 13 in the in the vertical direction, either way from our center. So our foci, I'll call foci number 1 the point 0, square root of 13, and focus 2 will be 0, negative square root of 13. Okay, so on my graph, I'm going to label this point focus 1 and this point focus 2. All right, and so the last thing I need to do on my picture anyway is just draw in that hyperbola curve. And so I go from my vertex out to each asymptote on either side. And that is my picture. So the last thing that I need to find are just my asymptotes. So again, the center is a point contained in both of those lines. So we'll start with our point slope form. So asymptotes, we'll have y minus 0 is equal to some slope times x minus 0. So all we need to do is figure out the slope. And to do that, again, just think about rise over run. So from the center to the corner of the box, we go up 2 and over 3. So our slope is plus or minus 2/3. And so our asymptotes are y is equal to plus or minus 2/3 times x. And that's all there is to it. Okay, so that was an example of both a horizontal and a vertical asymptote. And just keep in mind that unlike ellipses, A and B are not determined by their size, but by which variable they are underneath. So which variable has that positive and negative sign. Okay, so in the next example, we're given some information and we want to find the equation of the hyperbola. Okay, so just like we did with parabolas and ellipses, I would start by drawing a picture to see what this information looks like on a graph. Okay, so it says we have foci at 15, 0 and negative 15, 0. So let's just say that that's 15, 0. And let's say that this point over here is negative 15, 0. And it also says we have vertices at 9, 0 and negative 9, 0. So maybe 9 is about right there. So let's call that 9, 0. And let's call that negative 9, 0. So we notice first of all that this hyperbola is going to be horizontal. Okay, because our foci are located on the x-axis. And again, we're assuming that our center is 0, 0. All right, so we have a horizontal hyperbola, and because our vertices are 9 units in either direction from the center, we know that A must be 9. All right, we also know that our foci are 15 units from the center in each direction, so we know that C must be 15. So to actually get our equation, we need to find B. So we know that C squared is A squared plus B squared. And if we plug in A and C, we get that 15 squared is equal to 9 squared plus B squared. So we have 225 is equal to 81 plus B squared. And if we subtract 81 from both sides, we get that 144 is equal to B squared. So 12 is equal to B. Okay, so now that we've found our variable B, we can actually write our equation. So again, this is a horizontal hyperbola, so the x squared term will be the positive one. So we'll start by writing x squared over 9 squared minus y squared over 12 squared is equal to 1. And the last thing we need to do is just simplify those exponents. So we get x squared over 81 minus y squared over 144 is equal to 1. And that is the equation of our hyperbola. Okay, so hopefully that was a good start for you on some hyperbolas. In the next video, we'll talk about what happens when we move the center away from the origin. And we'll also talk about a different form of the conic equations called the general form.